briefly, I will briefly tell you about the tension members. Okay, so in that in tension members, their first thing is like the failure modes, right? The first is the types of tension member, isn't it? So this is a one topic. Before that, the definition, as you all know that the basic definition of a tension member is a member which is carrying a tensile load or called as a tension member, isn't it? So coming to the types, right? So the types, as we all know that the angle section, channel section, T section, I section. Okay, now. So these are the different shapes or the types of a tension member. Coming to the failure modes, failure modes of a tension member. As you all know that the three different failures, right? Due to cross section yielding, yes, due to cross section yielding, the tension member may fail due to cross section yielding. And then the other one is the second possible failure is rupture, right? Due to net section rupture. Can you see in the OneNote screen which I am writing? Yes, please respond. Yes, please. Can you see this that I am writing note? Can you all see this?
Yes,
Hello,
sir.
is the screen visible? Okay. Fine. So these are the three different failure modes as we all discussed in the previous in the theoretical offline classes, right? And based on this, we have discussed all the formulas. What is the formula to calculate the strength due to cross section yielding, right? And then what is the formula that is nothing but TDG, right? Similarly, the net section rupture. So here we have discussed the formula for net section rupture, that is TDN. Again, here the different formula, the formula is different for plates and for angle sections. Okay, and then last one. So as you all know that the third failure is a block shear failure, right? So here that is TDB. Okay, so these are the three different failures and then corresponding strengths are calculated. And then among these three, what is the least value that governs the strength of a particular tension member? Are you clear now? Yes, I think this, you just glance at all the things. OK, and next coming to the next after failure modes, we have calculated the strength carrying capacity, isn't it? Based on the failures, strength carrying capacity of a section, whatever the section, right? Maybe it is an channel section or I section or right or angle section, whatever it is. OK, so the strength carrying capacity. And then later on, after this, what we have done after this? So we have designed a tension member, design of tension member. OK, so here what we have done. So based on the load given, based on the load coming on a particular member. So we need to design, or you have to design the particular the suitable section. Say for example, say 100 kilonewton is a one load, which is a tension load. So for this load, you need to design a section. So you can suggest the section or the member as an angle section. Maybe in the problem or maybe in the design, they may ask you to design an angle section or design an channel section, right? So, or they may ask you to design choose or adopt an I section like that. Based on this, you have to choose accordingly and then to design. And then later on, on after this we have discussed design of tension splices. Design of tension splices. What do you mean by splices? In the offline class I already explained, and then we have done problem also. Before going on to the vacation, we have discussed the tension splice. Yes, please. Tension splice. Can anyone please tell me what is tension splice? Yes. It is similar to like a double cover butt joint. Double cover butt joint. You know what? Yeah, do you remember this? Double cover butt joint. Say, for example, if you require one member length of 3 meter, right? There you will be having only less length of the member. Say, for example, 2 meter length of the member. This is one member where you will be having right now in your this thing, right? You'll be having particular this much length, say 2 meter length of a member, but you require a 3 meter length or 4 meter length. So in that case, what you need to do? You need to join the members, right? You need to join. Say, you need to join one more member, which is of same 2 meter length, right? This one more member. OK, so this is one more length of 2 meter, same section. So that I'm going to join and then make it as a one single section called as a one individual member. In order to join this, we need one additional plate on top of this as well as on the bottom of this, right? So that this is acting as a cover plate. This is also a nothing but splice plate. You need to design in this case, particularly if you want to design a tension splice here, you need to calculate or design the dimensions of a splice plate, width of a splice plate, the thickness of splice plate, and then the length required. What is the length required? So you need to calculate all these three parameters, and then only the splice plate will be properly provided, and then it is behaving as a one member. I hope you all are clear with this topic, and then we have done problem also. I'm just glancing the things what are like covered, right? So now next, moving on to the next one more last concept in this chapter is design of lug angle. Lug angle. You know what lug angle? Anyone know about this lug angle? This also explained in class in offline class itself. Anyone, please? What do you mean by lug angle? Yes, if you know, you please tell me. Otherwise, I only will brief it out once again. Okay, I will just brief it out once again. OK, see, let me open this. No, not this. You know this one. This one. Can you see this PDF? Can you see this figure? One small figure. Yes, please. Hello.
Yes, sir.
OK, fine. See, this is a bracket plate where this is a main member, a main angle section. Can you see this angle section? So this is a thickness here with a yellow color, right? And then the corresponding bolts are provided. So like this, we have done some examples, right? Design of a tension member where how many bolts are required, and then accordingly the arrangement, and then accordingly we calculated all the three design strengths, right? So coming to the lug angle concept, in which, say for example, if the number of bolts provided are more means, say here how many bolts are there? 3 plus 3, 6. But actually based on the load, if the load is more, then the corresponding number of bolts will be more. Say for example, instead of 6, you may get 10 to 12 number of bolts. So what happens if you provide a 10 to 12 number of bolts? Say for example, the length of the connection will be becoming more and more. See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like that, you keep on providing to the, it is coming to the, I will just draw here. So the length, the coming to the length of a connection is becoming more, isn't it? So in order to avoid this adding a more length of the connection, so we need to provide, I mean, we should provide one more additional angle called as lug angle adjacent to the main angle, right? Can you see this one more blue color, a light blue color? Yes, please. This one, this portion. So this is an additional lug angle where it is provided to reduce the length of the connection and also to properly distribute the load in the connection. Okay, say for example, out of 10 or 12 bolts, 6 are provided, and then the remaining 4 or 5 bolts are provided adjacently here. So 3 bolts are provided here, and then the other 2 bolts are provided. See, this is the one example where I'm telling you 3 and 2 bolts. But when you actually take up one problem, so you will come to know the number of bolts required, like here, the connection between main angle to the lug angle here. So these are the two outstanding legs are connected. This is one outstanding leg of a main angle. This is one outstanding leg of a main angle. So both are connected. Okay. And then coming to the connected leg. This is a connected leg. Here 6 bolts are provided. And then this is also a connected leg of a lug angle. 3 bolts are connected. So likewise, overall, the number of bolts are distributed in such a way that the length of the connection is reduced, as well as proper transformation of the stresses or the forces will be taken place from one member to another member with this connection. So this is what the concept of a lug angle. Okay. Likewise, I told you to do this problem also. I explained in the class, even I just gave you an assignment problem, and then you just do the problem there on this lug angle. Okay. So with this, I just briefed out all about. I just briefed out. Once again, let me open this screen. Okay. So with this, I just briefed out all the concepts of the chapter 3, unit 3. Once again, I briefed out about the all the topics and then all the problems on design of tension members. Now we'll be moving on to the next chapter. Okay. So in continuation to that, okay, in continuation to the tension member, in the unit, in the 4th chapter, we are going to discuss about the compression members. Okay, have you all heard of this compression members? Yes, please. What is compression member? Anyone? It is same. It is same like a tension member, but the thing is that the members which are subjected to a compressive load. Yes, are you clear? Did you understand? The members which are subjected to compressive loads. Are you clear? So the members which are subjected to compressive loads. So these are called as a tension member, right? So if at all, if you want to define a compression member, how can you define this compression member? A compression member is a structural member which is a straight and subjected to two equal and opposite compressive forces. Say, for example, this is a member. So in RCC, in reinforced concrete structures also, we have discussed this compression member. So can you give me an example of a compression member? It is a column, isn't it? Column is coming under the perfectly suitable for a compression member, where it is subjected to compressive load, isn't it? Maybe the column is subjected to an axial load, or in addition to the axial load, there is a bending moment, right? So this is PU, and then one moment, okay, uniaxial moment, and then column with axial load plus axial load plus biaxial bending. Say this is one moment which is along x-axis MUX, and one more like this, right? That is called as in the another axis, that is MUY. So these are the three different compression members which were discussed in RCS, in reinforced concrete structures, right? So similarly in steel structures also, the compression members, the behavior of compression members are same. But coming to the types, what is the main or the best member which is suitable as a compression member? Yes, it is perfectly an I section. I section member is a perfect compression member, wherein which it is subjected to a compressive load, and it carries, it is more strong enough against the compressive load. Okay. Yes, please. In between, please respond. Okay. So now next, coming to the terminologies or the types of a compression member, right? So we can also call this compression member is as column member, or a strut member, or a stanchion. So these are the different names of a compression member in steel structures. Particularly in steel structures, we are going to call compression with a different names, compression member with different names, right? Those are as column, strut, stanchion, right? So these are the three different names. And again, in RCS also we have discussed the types of compression member: short and long. Do you remember this in RCS? Here also, long columns, short columns. Here also, the members which are subjected to, yes. How can you classify